Alright guys, we're going to be talking about periodic functions. Two periodic functions, A sine bx minus c plus d, or A times cosine b times x minus c plus d. A is the amplitude, b is equal to 2 pi divided by the period length. The phase shift includes two things, c, which is the horizontal shift, and d is the vertical shift. I refer to d as the axis. There are 5 critical points with the sine function. There's also 5 critical points with the cosine function. Let's look at sine first. The first critical point is on the axis, which, again, the axis is d. So the first point is on the axis at the beginning of the period length. PL is the period length. The second point, there's a maximum at 1/4 of the period length. So you take the period length times 1/4 to get the second critical point. The third one is on the axis at half of the period length. There's a minimum 3/4 of the period length. And the last one is on the axis at the end of the period length. So let's take a look at the most basic function of sine. Y equals sine x. This is the parent function that we wrote down last class. We need to be able to determine what A, B, C, and D are. And then we need to be able to translate those into amplitude, period length, axis of rotation, and phase shift. So what is A? What number is in front of the sine?
1.
There's a 1 in front of that sign. B is the number in front of x. What number is in front of x? Should be 1 again. C is the number added or subtracted to x in parentheses, like the original function on the first screen showed you. Is there anything added or subtracted to x in parentheses? No. A nice hint is if there are no parentheses, there is no c. If there are no parentheses, then there is no c. There's definitely no c. And is there anything added or subtracted to the whole function? No, so d is 0 also. And this is what makes this function the parent function. A and b are multiplied, and they're the most basic multiplier, which is 1. C and d are added, and they're the most basic add or additive thing, which is 0. The period length is something that we need to figure out. I told you that b is equal to the period length, or 2 pi divided by the period length, which means the period length is 2 pi divided by b. So you need to be able to figure that out. All right, so the period length here is 2 pi divided by 1, which is just 2 pi. I set these up. The way that I set up the graph is first by using the axis. The axis is the horizontal line that this graph is going to rotate around, and that horizontal line is 0. I make the axis a dotted line because it's not always going to be on the x-axis, and it's an imaginary line that divides the graph in half. After that, I put the amplitude. Amplitude is equal to whatever A was. So the amplitude is 1. And that goes above and below the axis. So -1 and +1 are the points or the values that we get when talking about the amplitude of 1. And then the last thing that I do is I take into account C. C is the left and right, which means I don't go left or right any. And then I add to that the period length, which is 2 pi. And then I mark 2 pi on the axis. Now, if you remember the critical points. The critical points occur at the beginning, the 1/4 of the way, half of the way, 3/4 of the way, and then the very end. The best way to do that, in my opinion, is to first take this period length and cut it in half. 2 pi divided by 2 is just pi. And then take this little section here and cut it in half. You don't even have to create a label for it. And then take this section and cut it in half. And if we take the critical points into consideration, we know that at the beginning, there is a point on the axis. And then we know that there is a maximum at 1/4 of the period length. There is a point on the axis halfway across the period. There is a minimum 3/4 of the way, and then there's a point on the axis halfway across, or all the way across. And then you connect the dots with a curve. Let's look at the next pattern of critical points for cosine. There's a maximum at the beginning of the period length. The second critical point is on the axis 1/4 of the way. A minimum halfway across. A point on the axis 3/4 of the way. And then a maximum at the end of the period length. So this one kind of looks like a V. Or a U, depending on how you draw it. All right, so here we're going to talk about cosine, the parent function of cosine. The A, B, C, and D are the same as the parent function of sine. So A is equal to 1, B is 1, C and D are both 0. And again, these things correlate to amplitude, period length, and then phase shift. Has to do with both C and D. So the amplitude is 1, the period length is 2 pi divided by 1, which is just 2 pi. C is 0, and the axis, again, is 0. Alright, so again, I start with the axis. I label it with a dotted line. The axis is 0, so it just so happens to be on top of the x-axis. The amplitude is 1, so above and below the axis is the amplitude. And then the period length is C plus 2 pi, which is just 2 pi. And that's how I begin labeling my trigonometric functions graphs. And then you take this 2 pi and cut it in half, and then take pi, cut it in half. 3 pi over 2 is halfway between pi and 2 pi. And the pattern of critical points for cosine is a maximum at the beginning, an axis point 1/4 of the way, minimum halfway, axis point 3/4, and maximum at the end. And whenever you connect, there's your graph of cosine